All right, so I think this is recording. Let's take a look at these two problems. We're looking at quadratic inequalities now. Um, the the first thing I'm going to do is just ignore that it's an inequality and write it as an equation. So I'm going to look at x squared minus 4x minus 12 is equal to 0. And I'm going to solve this equation. Now, the quadratic formula will always solve this equation, but many times we'll be able to factor it with the leading coefficient of 1. It's not that difficult to factor. We see that x minus 6 times x plus 2 will do the trick, because the negative 6 times a positive 2 gets us the negative 12, and when you add negative 6 and positive 2, you get negative 4. All right, so this has two solutions, x equals 6, x equals negative 2. So negative 2 and 6 is to the right of negative 2. Now, let's go back to the original inequality. It was less than or equal to. So I'm going to think of these as boundary points on my number line. And because it contains equality, because that's underlined, these are going to be shaded. Now, there's different techniques to now determine whether to shade or not shade each of these regions. These 2 points split the number line into 3 points. But I suggest that you think about what the graph of x squared minus 4x minus 12 looks like. It's a parabola. And with this leading coefficient being positive, it's a parabola that opens upward. And it passes through these 2 points. These 2 points are the x-intercepts for this parabola. Now, if I'm wanting the values of x such that this arithmetic results in less than or equal to 0, less than 0, the output that's below the x-axis. So I'm interested then in the values on this number line that result in the y-coordinate being below the x-axis. So all of these points on this parabola, the one thing that all of these points have in common, well, two things. They're between, the x-coordinates are between negative 2 and positive 6, and all of the y-coordinates are negative. It's below the x-axis. So that tells us what our solution is. That tells us that if you pick any number that's negative 2 or larger all the way up to 6, that any value that's between negative 2 and 6, including those endpoints, and you plug that number into this expression, you do this arithmetic, and you're going to get a number that's less than or equal to 0. If you pick a number that's less than negative 2 or bigger than 6, and you do this arithmetic, you're going to get a number that's greater than 0. It's not going to satisfy this inequality. So here we found our solution, and we found it by thinking about what the graph looks like. And you know what x squared looks like. You know that the graph is called a parabola. That's probably, I believe, the easiest method in solving these quadratic inequalities. Let's take a look at this number 2. Let's get this in standard form. 2x squared minus x minus 10 is less than 0. But initially, I'm going to set this inequality as an equation and try to factor it or use the quadratic formula to solve this equation. So this time, my leading coefficient is not 1, so the x method is probably going to be a nice tool for us to use to factor this trinomial. So the middle term here is at the bottom of our x. At the top of our x, we take the first term times the last term, which is negative 20x squared. And we think of two numbers when multiplied together give us the top value, but yet when added give us the bottom. And negative 5x and positive 4x do the trick. And now since this leading coefficient is bigger than 1, I'm going to write this information in the form of a table and use the table as an organized way to apply the distributive property to factor this. So along one diagonal goes my first term and last term from my original equation, and along the other diagonal goes the values that I found in the x, the negative 5x and the 4x. Now, along these diagonals, these are interchangeable. It doesn't matter if I put that negative 5x in the upper right or lower left here. Now I'm going to factor each of these. I see that these are both even numbers, so they are both divisible by 2. I see that negative 5 divides both of these, that negative 5 is a common factor to both of those. Horizontally here, I see that x is a common factor to each of these, and vertically here I see that 2x. And if I do a quick check, if I multiply these outside entries, I should get the inside body of the table, and it looks like that I do. You can double check that. Now, let's return to this equation. So now this trinomial can be written as a product of two binomials. We can factor it. We can factor it to x plus 2 and 2x minus 5, and that equals 0. And we can solve this equation now by splitting this into two equations where x plus 2 equals 0. That gives us a negative 2, or that 2x minus 5 equals 0, and that means to add 5 and divide by 2, and we now have our two solutions. Let's put those on a number line. Negative 2 and positive 5 halves. 5 halves is 2.5 if you like to think of it as a decimal. Now, I need to return back to the original inequality and decide whether I want these to be hollow points or solid points. Are these numbers going to be included in my solution set? If I still have the first problem up here, it was less than or equal to. You see that underline? That's the decision, that was the determining factor to make these solid points. Here I have a strict inequality, so I'm going to leave both of these as hollow. All right. So now I'm going to recognize that 2x squared minus x minus 10 is a parabola that opens upward because 2 is positive. So if I draw a parabola through here with these 2 points being the x-intercept, and I ask myself, well, on this number, what values of x will cause the y-coordinates to be less than 0, to be below this x-axis? And it's, again, it's in the middle values. If you pick any x that's bigger than negative 2 but less than 5 halves, and I guarantee you that the y-coordinate is going to be negative. You pick any value of x that's bigger than 5 halves or smaller than negative 2, and I guarantee you that y-coordinate, you're going to be above the x-axis, and that above the x-axis has y-coordinates that are positive. We only want this arithmetic to result in a negative number. So we have our answer. Here, let's shrink this up. Let's write our answer using interval notation. We can get it now from the sketch of our graph. And we see it's similar to the last answer. However, we have parentheses instead of brackets. Negative 2 is excluded from our solution set, and 5 halves is also excluded. So here's our answer using interval notation. I hope that helps, and I will talk to you later. Bye.